Welcome to Learning Chemistry with the Professor's Dubois. Today, we will learn how to determine an empirical formula from elemental percent composition. If you need a refresher on what chemical formulas are, watch our video on molecular and empirical formulas, then come back to this one. You may be wondering why we would even bother with an empirical formula, as it may or may not be the actual formula of the molecule. Chemists are often trying to identify an unknown substance, and a common approach is to decompose it into its elements and measure how much of each element is present. In this type of analysis, our instrumentation provides a mass percent of each element in a compound. From this, one can determine the empirical formula of that unknown substance. So, what is meant by mass percent? As the name implies, it is the mass of one element as a percent of the total mass of the compound. Water is 11% hydrogen. This means that for every 100 grams of water, 11 grams is hydrogen and 89 grams is oxygen. Mass percent is an intrinsic property, which means it does not depend on quantity. You can have a pint glass or a swimming pool and water would still be 11% hydrogen. Let's say we have a compound that has the following percents and we wish to determine its empirical formula. The formula represents the ratio of atoms, or the ratio of moles of atoms. So we need to determine the mole-mole ratio of these elements. If we knew the mass, we could calculate the moles. Okay, here's the key to solving these problems. Assume we have 100 grams. This simple assumption changes the percents to masses. Now back to our problem. The next step is to convert these masses to moles, using the molar mass from the periodic table. For chemistry problems, avoid cross-multiplication and cancel units instead. This is a mole-mole ratio, but a formula represents the smallest whole number ratio of atoms in a compound, and numbers of atoms cannot be decimals. The next step is to divide each of these moles by the smallest one. You are sure to make at least the smallest into a whole number, 1. In this case, all of the elements turned out to be whole numbers, and our empirical formula is CH5N. Sometimes the ratios are not all whole numbers after dividing by the smallest one. In that case, you will need to multiply all of them by the same factor to obtain whole numbers. In this example, we need to multiply all of the elements by 2 to obtain whole numbers. Remember, the result is the empirical formula. You may also need to determine the molecular formula in the same problem. See our video, Molecular and Empirical Formulas, for help with that step. Thanks for watching, and subscribe for more videos to learn chemistry with the Professor's Dubois.